So in this video, we're going to go over how to determine intervals over which a function is increasing, decreasing, or constant. I've typed up a formal definition that you could probably do well to spend some time perusing. I am going to try to give a more informal understanding of what it means for a function to be increasing, decreasing, or constant over an interval. The one thing from the definition I do want to pay particular attention to is the fact that we have defined increasing, decreasing, and constant functions over open intervals. So remember, open intervals are intervals where we use the parentheses. So I could have the open interval from -5 to 2. This is an open interval. And when we have an open interval, we are excluding the boundaries of the interval, as opposed to a closed interval where we include the boundary numbers as part of our solution, so to speak. So when we're working with defining intervals over which we're increasing, decreasing, or constant, we're going to be using open intervals to do that. I noticed in the homework platform sometimes that they define increasing, decreasing, constant intervals as closed intervals. In general, though, I don't think the majority of us would do it that way. It's typically something that's defined over an open interval. Here's the idea. We're going to be moving along the input or x-axis from left to right. And when we're defining intervals over which the function is increasing, decreasing, or constant, we're describing the x values or the input values over which the function is increasing, decreasing, or constant. And the idea is, as we move from left to right, the function, as we move from left to right on the input axis, the function is either descending or decreasing. In other words, the outputs are getting smaller and smaller. Or, as we move from left to right along the input axis, the function, if it's a continuous function, it might be increasing over that interval or going up, where the output values are increasing in value. The function, as we move from left to right along the input axis, when we look down at the function or up at the function, we might see that it's constant over an interval, or again, that it is going up or increasing. And our job is to define those intervals over which the function is going down, going up, or flat, or in other words, remaining constant. So you always start from the furthest left, right? We want to look up here. We have an arrow on our graph, which means the input values are going infinitely far to the left, so they're going out towards x in the negative infinity direction on the x or input axis. This arrow has a vertical component. It tells us that the output values are going towards infinity with respect to the y-axis or the output axis. But as we move from left to right along the input axis, what we notice is that the function outputs are decreasing. In fact, they decrease until they hit a low of -4 at this point right here. This looks like it's probably the point -2 and -4. So as you move leftwards, they're going towards positive infinity, but as we move towards the right on the x-axis, they're dropping to this low point of -4. So the function over this interval is a decreasing function. So I'm going to identify that I have a decreasing function, and I need to say for which values of x is the function decreasing. So I say x is an element of the interval, and as we move from left to right, we're coming from negative infinity, and we're going all the way up to the x value where the function hits this low point, and that was at x equaling -2. We wind up with this low point at -4. We want to define our decreasing interval as an open interval. So when we get to -2, the function stops decreasing. And once we get past -2 along the x-axis, we see that the function begins to increase. fact, it's going to increase to a maximum of -1 right here. When x is 0, we get an output of -1. So it increases as we move from -2 to 0 along this interval right here. As we're moving along this interval right here, the function values are increasing from -4 up to -1. So we have an increasing function over that interval. So x is an element of, we're increasing on the interval, we're picking up where we left off here, increasing over the interval from -2 to 0. Again, these need to be the x coordinates. So the x coordinates over which the function is increasing run from -2 to 0. And then we see here from the point, this is 0, -1, all the way over to right here. This looks like we're out at 1, 2, 3. At 3, -1, the function outputs are always -1. Between 0 and 3, the outputs are constant. They're -1. So we have an interval over which the function is constant. So x is an element of starting at 0, not including 0, running all the way over to 3. We have an interval, an open interval over which the function is constant. And then we see once we get past 3, so as we move past 3, as the x values move past 3, the function is increasing in value up until we get here. And here I have a solid dot, a solid point that indicates that the graph stops at 5, an input of 5. There's the input 5, output 5. So the function's increasing between 3 and 5. So I'm going to add on to this right here where I'm identifying where is the function increasing. I'm going to say union. There's another interval over which the function is increasing. Union. It is increasing on the interval from 3 to 5. And even though a solid dot generally means that you're including the input of 5 for the function, our increasing intervals need to be open intervals. We're defining everything over open intervals. So there are the intervals over which this particular function is increasing, decreasing, or constant. So do another example. So here I've got an arrow. So this indicates that the function is going infinitely far in the x direction. It's going towards -infinity, and it's going down. I have a vertical component for this arrow. So in the y direction, or output direction, it's going down towards -infinity. And I can see as I come from -infinity along the x-axis up to this local maximum right here, I can see that over that interval the function is rising or going up. It's increasing. So I have an increasing function. So my function is increasing. X is an element of what x values? I started out towards -infinity and I ran all the way up to, and it looks like our tick marks are counting by 2's. So that's at x equaling -2, but I want to make an open interval there. So between -infinity and -2, the function is increasing in value. And then once I get here at -2, the function decreases or descends all the way until I get right about here. And I'm going to need to estimate that. 2, 4, that looks like we're probably at -1 and maybe -5. So we want the x values. So this is as we run on the interval from -2 to about -1. The function is descending or decreasing. So I'm going to say, hey, the function is decreasing. When is it decreasing? Well, x needs to be an element of the interval from -2 to, I don't know why I put a -1. I don't know why I put a -1 there. That's about the dumbest thing I've done today. That's an input of about 1 and the output is about, that's about -5. So over the interval from -2 to 1, I mark myself off for that one. Looks like the function is descending or decreasing, and then once we get to this local minimum, the function is going to increase again. It goes up. It's going to increase until we get here, which is coming up short of the tick mark. So we'll need to estimate that. If these are counting by twos, this is 2, 4, 6. 5 is here. Maybe that's a 5 point. This is going to have to be estimated. Maybe that's a 5.7. So we'll say at about 5.7, the output is 2. And that's an estimate, and sometimes we're going to need to do that. So we're increasing, so I'm going to go union. We start at +1 and we roll over to about 5.7. The function's increasing over that interval. And now it decreases again. So between that between that +5.7 and that looks like exactly at 8, between 5.7 and 8, the function's going down, so it's decreasing. We're going to pick up where we left off. From 5.7 to 8, we're increasing, and now we're increasing again. So union, starting at 8, the function goes up, and I have an arrow here, so that tells me that we're going up, and the function goes infinitely far to the right, so the x values are going to infinity. So on the interval from 8 to infinity, the function is increasing in value. So here's my increasing intervals, here's my decreasing intervals, and then this is one where the function isn't constant. The function is not constant over any interval or over any open interval. I probably should use the word open there. I could just erase it. Over any open interval.